talk about gravitational potential energy. Potential energy, you remember, is energy due to position. So, gravitational potential energy is just energy due to position in a gravitational field. Now, we're always going to have some zero. This is our y equals 0. Usually, it's the ground, or it's somewhere convenient. Say I have a box up here. The gravitational potential energy is going to be equal to the mass of that box times g, that's the force going down, times my height above my 0 point. Now, clearly, I can move my 0 point. If I move it up here, then I will have some h1, and the potential energy will be different. So, I like to tell my students to pick your 0 point smart. Alright? In general, you're going to want to make your origin someplace so that one of your energy goes away or something is reasonable and simple. You can put your origin at the center of the earth, but it's going to make your calculations a lot harder. Now, Larry weighs 630 newtons. He climbs up a ladder to a height of 5 meters. Does Larry do work? Well, yes he does, because work is force times the distance. How much work does Larry do? Well, he's hauling his weight up a height. So the work Larry does is 630 newtons times 5.0 meters, and 630 times 5 is 3,150 joules. Now, what's his gravitational potential energy before he starts climbing? The answer to that is, well, it depends. Where do you want his origin to be? Tell you what, let's stick Larry on the ground, and let's say this is y equals 0. If you're smart, his gravitational potential energy start with a 0. Now, what's his gravitational potential energy at the top of the ladder? Well, GPE is mgh. I don't know his mass, but I could find it. Mass is his weight divided by gravity, so this is his weight times height, so it's 630 newtons, times 5 meters, or 3,150 joules. Oh my goodness, look at that. His work is the same as the change in gravitational potential energy. Fill in a theorem, come on. Alright, suppose I have a rock climber. I have a 90 kilogram rock climber climbing 45 meters up to the top of the Enchanted Rock. What's its gravitational potential energy at the top of its climb? Now folks, in general, if we've got some mountain up here, our gravitational potential energy is going to be with respect to how far he could fall and then hit the ground. So we're going to call that his h. That was really horrible, so let me erase it. Okay, so we'll do our mountain like this. How does that sound? So my height is just straight to the ground. So his mass is 90 kilograms. His height is 45 meters. So his gravitational potential energy is mgh. Now folks, I very rarely write GPE. Usually I just do PE is mgh. So his mass is 90 kilograms. Let's see, g is 9.8 meters per second squared. And the height is 45 meters. So, put this in your calculator, you get 39,690 joules. Now he climbs back down to the ground 85 meters below the top of the Enchanted Rock. Use the initial height as a reference point. Calculate his potential energy at the bottom of the climb. Okay, let's look at this. So he goes up 45 meters. Okay, so this is 45 meters. Okay, so that's his 0 point. And then he goes down. Okay, I'm going to change colors here. And then he goes down 85 meters from the top. So his change in height is going to be, what is it? What's 45 minus 85? He's going to wind up being 40 meters down here. It's going to be plus 45 meters minus 85 meters, or negative 40 meters below his starting point. So what's his new gravitational potential energy? Well, potential energy is mgh. So it's his mass, which is 9 kilograms. G, which is 9.8 meters per second squared. And the height is negative 40 meters. So I'm going to get negative 35,280 joules. You can have negative gravitational potential energy. Kind of cool. Now, I have a spoon, which is 21 centimeters above the table. The spoon is raised 21 centimeters above the table. If the spoon and its contents has a mass of 30 grams, what's the gravitational potential energy? Okay, heaven help us, I'm going to do a diagram. There's my spoon, here's my tabletop. This is 21 centimeters. So, my height is 21 centimeters. Now, you know I have to convert this to meters. Under centimeters is 1 meter. So this is 0.21 meters. They have a mass of 30 grams. And I know 1,000 grams is a kilogram. You must put everything in MKS, meters, kilogram, seconds. So this is, let's see, 30 divided by 1,000. You can count your zeros. 1 0 cancels. That one moves to the front of the 3, and that one is an additional 0 in front, so 0.3 kilograms. So, potential energy is mgh. So the mass is 0.03 kilograms. G is 9.8 meters per second squared. And the height is 0.21 meters. So I get gravitational potential energy of 0.06027 joules. Now, calculate the increase in gravitational potential energy of a 75 kilogram hiker who climbs to 1,500 feet. What this means is he's going to go up a height of 1,500 meters. So the potential energy is mgh. The mass is 75 kilograms. G is 9.8 meters per second squared. And the height is 1,500 meters. Calculator, you get 1.103 times 10 to the 6 joules. Now, if 2 joules of work is done, raising a 180 gram apple, how far is it lifted? Remember, work is a change in potential energy. So the work is a change in potential energy, which is mgh, which is 2.0 joules. The mass of the apple is 180 grams. Can't leave it in grams, got to convert it to kilograms. I know 1,000 grams is 1 kilogram. So this is 1, 2, 3, 0.180 kilograms. So, potential energy is mgh. I want to know how far it's lifted. So I'm going to divide both sides. There's my mg. My mg is, so the height, I'm going to lift this, is going to be the potential energy divided by the mass of g, which is 2.0 joules, divided by 0.180 kilograms. this is an interesting problem. I have a force of 15 newtons drags the cart up an incline. How much work is done? Now you remember, work is force times distance. So the force is 15 newtons. And you're going to write your given value. F is 15 newtons, and it goes along an incline of 0.9 meters. V is 0.9 meters. That's apparently point B. So the work is force, which is 15 newtons, times the distance, which is 0.9 meters. Put this in your calculator. 15 times 0.9 is 13.5 joules. Now, what's the cart's potential energy when it's 1.2 meters above the ground? So, my height is 1.2 meters. So, the potential energy, well, I need the mass, don't I? That's interesting. Can't do this one. No mass. Tell you what, let's just say it has a mass of 2 kilograms, just for the giggles. I like doing this. So,